All right, so here's our wrap-up video. We learned these new properties. The main ones are the derivative property and the convolution property, just listed in both the forward and backward directions. And then there was that piecewise property that I told you to make a note of for your own reference, but that we're not really going to come back to. We did some examples with the derivative property in the forward direction so that we would be able to see it when it showed up in the backward direction for this differential equation example. And it went pretty quickly because of that. And then we went over the definition of a convolution, which takes a bit of integration, and it sort of came out of nowhere. And we did an example where you could use the convolution property in the forward direction, but I warned you that computing f star g for this property is not really necessary or useful in the forward direction. So we did a backward direction example, taking the inverse Laplace transform of a product that gives us a convolution to show why we need to compute that integral so that we can find our solutions x of t. And it took a bit of work, but we did get the same answer as we had from the other approach to the problem. And so we talked in a little bit of detail about when to use these different properties. And I actually summarized these again in the wrap-up, so don't worry about it for right now. But if the wrap-up is too brief, go back and read this because it's important for knowing when to use those things. We talked about how f star g can show up as in something called an integral differential equation, but it's sort of like what we did with step functions and whatnot, where you do have to manipulate it so that it looks like that f of t minus tau, g of tau kind of shape. And then in preparation for the next section, I tried to help you build intuition for what a Dirac delta function is. If you've seen it in other classes, great. If not, hopefully this helped a little bit. We're going to be working with it next section. So to recap, we talked about the derivative property. The forward direction, taking the Laplace transform, is pretty simple, and hopefully you can see when it shows up. The inverse Laplace transform of something that uses the derivative property can be hard to identify, so I told you to just sort of know a couple of cases that you might be able to fall back on. The convolution property, the Laplace transform of a convolution is unusual when it comes up. The inverse Laplace transform of a product that leads to a convolution is really flexible, but it's also really time consuming. And then I noted that we went over the Dirac delta for next class. So your practice problem is this right here, just to compute the inverse Laplace transform of 1 over s times s minus 1. In prior classes, we would have done a partial fraction decomposition for that. So why don't you try it with the convolution property and then tell me if you would prefer fraction decomposition or convolution for that. So work on that, and I will see you in class.